Thank you. Good morning, ladies and gentlemen. I hope you can understand me. What you can see here on this picture is our wastewater treatment plant in Bottrop. Yes, it's one of our big wastewater treatment plants, but I show you later where I come from. My presentation is about the possibilities of sludge disintegration, and this is worked out with my colleague Ole Koplow. He is working for the Niersverband, but he is also a member of this specialist group of the DWA. We have this specialist group. Later I will talk a little bit more about this. My content, a short introduction, and then I want to give you a definition what sewage sludge disintegration means, and then a little bit about application, possible application areas, some different methods for disintegration, some results, overview about results, and a little bit about best practice for installation, and at last a short summary. So my name is Karl-Georg Schmelz. I'm 56 years old, and you can see my family there. I'm working since 1990 for Emscher Genossenschaft and Lippe-Verband. I have different working areas currently in the research and development department in our water board, and I'm responsible for sewage sludge and industrial wastewater treatment. And I'm a member of different specialist groups of the German Water Association. For example, this DWA CAC 1.6, and this is sewage sludge disintegration. And I'm also engaged in the education of the staff of the wastewater treatment plants operators, and the students at the University Duisburg-Essen. So where I come from, where I am working, I'm working in the west part of Germany, and here you can see this is here is Europe, and this is Germany, and this red is North Rhine-Westphalia, the west part of Germany. And in North Rhine-Westphalia is the area of Emscher Genossenschaft and Lippe-Verband. The blue is the Emscher Genossenschaft. This is the Ruhr, so-called Ruhr area, this industrialized area in the west part of Germany, and in the north this is the area of the Lippe-Verband. You can see inside the river Emscher and the river Lippe, they are flowing into the river Rhine. And here you can see our catchment area a little bit more. Here are our inhabitants in Emscher Genossenschaft, 2.2 million inhabitants. And you can see all of these little brown digesters. This means this is there we have a wastewater treatment plant, but not every wastewater treatment plant has a digester, because we have also some smaller wastewater treatment plant, less than 10,000 PE, they have no digester. They are only a symbol for a wastewater treatment plant. So enough of this. I'm a member of this specialist group, the German Water Association Specialist Group, CAC 1.6, and this is about sewage sludge disintegration. And what you can see here is this Merkblatt. This is the guideline, and this is published last December. And this specialist group, where I am a member of, is working since 1996, and we have published 6 working documents. And what we have done then is to make a more or less a summary in this guideline of these 6 working documents. And the members of this group, Johannes Müller-Scharper, he is the speaker of our group, and the other, you can see, Ole Koplow. I made this presentation with him together, and some more members. Yeah, definition of sewage sludge disintegration. Disintegration of sewage sludge through the impact of external forces, and this may be physical, chemical, or biological forces. The degree of disintegration depends on the method you use, the procedure, the energy input, and the characteristics of the sludge. And if you want to have a disintegration of rocks, then you're reducing the particle size and the destruction of microorganism chains. Then you need only a low energy, less than 0.1 kilowatt hour per kilogram dry solids. But if you want to get a disintegration of the cells, of the microorganisms, then you need more energy, more than 0.25 kilowatt hours per dry solids. What are the objectives? Objectives are increase of bioavailability of organic carbon in the sludge and sometimes also improvement of the sludge characteristics. So once again, what is disintegration? Disintegration of sewage sludge is the application of physical, chemical, or biological forces, and that leads to a destruction of flocks or a disruption of microorganisms. This is disintegration. And this leads to a decrease in particle size and an increase in soluble compounds, carbon, nitrogen, phosphorus. You can see these two pictures here. This is the sludge, the untreated sludge. You can see big blocks and big particles. And here, this is the disintegrated sludge. You can see only small particles. This is the effect of this disintegration. So here you can see it again, the decrease in the particle size and the increase in soluble compounds. Here you can see the specific energy. As more energy you use, as more the particle size decreases and COD releases increases. This is the effect of the disintegration. So possible locations for a disintegration unit on your wastewater treatment plant maybe in the effluent of activated sludge, but you have to treat all volume. This is not very effective. Mostly used is this in red for the surplus sludge, disintegration of surplus sludge, for feeding the surplus sludge into the digester. Other common methods are disintegration of floating sludge or foam and disintegration of the cycle heat in the digester. This is also a possible method. Areas of application, a selection about this. Mostly wide used is optimization of the digesting process. And the target is to increase the biogas production, reduction of the sludge amount, and the improvement of the dewatering behavior. Yeah, these are the most widely used targets for disintegration. Also, it is used for the prevention or reduction of operating problems, reduction of bulking, sludge and foam, improvement of settling characteristics, prevention of cloggings, and reduction of sludge viscosity. These are only possible application areas. But we also be aware that we have some secondary effects. If you make this disintegration, for example, of surplus sludge, we will then go to the digester to have a better degradation in the digester. We will have an increased return load of the wastewater treatment plant. Yeah, more COD, nitrogen, phosphorus, and sometimes particles. Due to the reduction of the particle size, because we are making the particles very, very small with the disintegration, and if we then go to the dewatering unit, sometimes we need more polymers or other polymers. Yeah, this is also a secondary effect on the dewatering unit. We are formulating organic compounds with low bioavailability, especially in this disintegration methods where we use high temperatures. Yeah, we are building bad or low degradable COD compounds. Yeah, so we have to be aware of this. And we have an increase of pollutant concentrations, for example, heavy metals, because we have a better biodegradation of the organic matter in the digester, the concentration of heavy metals increases. And sometimes we have problems with order. Yeah, we operated a small Cambi plant, a Cambi pilot plant, and if you are cooking this surplus sludge with 160 degrees, Yeah, you have a special smell that produces odor. So, sorry, this was wrong. So some methods, this is a list of some methods of disintegration for sewage sludge. Then we have some possibilities for mechanical disintegration. You can use ultrasonic mills, ball mills, high pressure homogenizators, laser centrifuge or other. You can use heat treatment with a temperature range from 80 to 180 degrees. Oxidation processes mostly used with ozone. Biological treatment mostly used with enzymes. Chemical treatment using acids or alkali. Freeze thaw treatment, not very common, but combinations. You can combine heat with chemicals or mechanical, biological, or ultrasonic with temperature or other things. Combinations. But mostly widely used are this in red. Ultrasonic, you can find it on different wastewater treatment plants, also in Germany. The heat treatment, laser centrifuges are also used. Ozone for oxidation processes, for biological treatment, mostly enzymes and heat and chemical treatment, disintegration. So these methods are all available for full-scale operation. Some examples are following ultrasonic disintegration. What is done by ultrasonic disintegration? We generate acoustic waves with a high frequency, more than 20 kilohertz, and then that leads to compression and expansion of the medium, and then we get cavitation and collapse of steam bubbles. And this is the destruction of blocks and cells through shear forces by this implosion of these bubbles. And here you can see an example. This is VTA, the VTA company. They are selling this system for ultrasonic disintegration. You can see these tanks, these reactors. Here, these are the reactors. Here is the surplus sludge input. The sludge is going inside. There is a stereo inside and 2 or 4 of these sonotrodes, and they are producing this ultrasonic disintegration in this reactor. Yeah, the sludge flows in here, and then you have this ultrasonic treatment, and then the disintegrated sludge goes out at the top. Another example is this disintegration unit from ultrawaves or sonotronic. You can see here the sonotrodes. The sludge, the surplus sludge, flows in here, and then it flows against the sonotrodes, and then back against, and then the disintegrated sludge goes out here. You can buy this unit in the box and install it in your wastewater treatment plant for surplus sludge. Thermal disintegration, we need the input of heat. If we have temperatures lower than 100 degrees, we have a normal pressure. With more than 100 degrees high pressure solutions, we use heat exchangers or with the high pressure steam injection. We have chemical and physical reactions. We have changes in the cell structure. We break up the biological chemical structures, and from 170 degrees up, we increase hardly biodegradable compounds. This is called the Maillard reaction. So Cambi and all the other thermal disintegration units are working with temperatures between 140 and 160 degrees, not more than 170 before we build this hardly biodegradable compounds. In former times, we had with the Emscher Genossenschaft the so-called thermal conditioning unit. I don't know if you have heard about this thermal conditioning. This is what was working with 220 degrees for half an hour reaction time, and be producing very, very a big amount of hardly degradable COD compounds. And this was working till the beginning of the 90s, because we also have a lot of nitrogen release. The nitrogen comes back And in the 90s and late 80s in Germany, we have to eliminate also nitrogen from the wastewater, so this was a little bit counterproductive to make a cooking of the surplus sludge and take out all the nitrogen and put it into water and then to the river. So we gave it up in the early 90s of the last century. Yeah, thermal hydrolysis provider companies are Cambi or Veolia, Stulz, Aslev. We will hear a little bit more about in the next presentation. And the working temperature between 150 and 170 degrees. And the input of heat is generally by steam injection, generally. This is a Cambi process. The sludge comes here, it has to be dewatered, and then it goes in the storage tank, sludge silo, and then the pre-treatment, preheating to 95 degrees, and then it goes to the reactor. The reactor working with 165 degrees, 8 bars for 1 hour, and then we go into the flash tank and 2 bars for 60, maybe 1 hour, and then it starts cooling, and then we go to the digester. The targets are to get a better degradation in the digester, higher biogas production, and better degradation of the solids. But you will hear a little bit more in the next presentation. Another method for thermal disintegration is this example Stulz. Usually it's called Isotherm, and here you can see the sludge can be here. It's the preheater, and then we go to the next step. This is working with thermo oil, and then it goes heated to 160 degrees, and then it goes to the cooling level, and then it goes to the digester. Another example for a chemical thermal disintegration is Fondos. Fondos also a company providing this. Here you can see the primary sludge. The primary sludge, we have nothing to do with primary sludge. Primary sludge is good, biodegradable, so it goes directly to the digester. But the surplus sludge, the secondary sludge here, you put there to the secondary sludge a little bit sodium hydroxide, and then it goes into this reactor, and this reactor is heated to 60 to 90 degrees, and then we have here a little retention time, and then it is mixed with the primary sludge and then feed it into the digester. This treatment temperature between 60 and 90 degrees, and then it goes about 2 liters per cubic meter sludge to the sludge, and use exit heat of the CHPP by heat exchanger, and we have several operating facilities in Germany, and this is, I think, it's a picture from Gifhorn, and the capacity of this unit are 700 to 1,000 tons dry solids per year. This is made for surface sludge. Enzymes are catalyzing degradation. Enzymes are specific for substrate and affect the key lock principle. You know this should speed up the degradation of long-chain compounds. And the seller of this enzymes, they ask, okay, we need a start-up dosage at the beginning, kind of inoculation, and then a further dosage dependent on sludge amount. So if we make a kind of assessment of selecting techniques, ultrasonic is simple to integrate, a low investment, but limited effects. We have more biogas, but low effect on dewatering results and effect directly dependent on energy input. As more energy you take in, as more biogas you will get. Reasonable for poor working digesters. If your digester is not good working, maybe you can make a better digestion if you use this ultrasonic degradation unit. Thermal disintegration is a medium investment for thermal chemical disintegration. This is for medium-sized wastewater treatment plants. But if you want to realize the thermal hydrolysis, then you have high investment, and this is only suitable for big wastewater treatment plants, I think. And we have a significant increase of gas production and liquidation and improvement of the watchability. This you can find with this thermal disintegration units, or Cambi or all the other, they are on the market. Enzymes, if you have enzymes, you only have product costs, more or less only product costs, but the enzymes are expensive. Yeah? Very low investment, you only need a storage tank and a small pump, and that's it. Yeah? But very limited effects. A little bit more biogas you can find, less than 10% in improvement of clotting problems sometimes, and very specific on the sludge. This is very, very specific for the sludge you have. So some results. This is the first part of the table. Some results for mechanical, thermal, electromagnetic methods. Mechanical, you can have between 0.5 to 20 kilowatt hours per cubic meters. Or you can find the results. Mechanical, thermal, high performance, electrokinetic. I'll go over this. This is the next slide is chemical, biological, and combinations. Thermal chemical equalizers, oxidation with ozone. You can see what are the results and some remarks about these techniques. If you think about to install this integration unit on your wastewater treatment plants, you have to think what are the targets for you. The targets for the degree of disintegration. If you need only a little disintegration, degree of disintegration lower than 10%, then you have the generally required energy. This for the disintegration is low, less than 10 kilowatt hours per cubic meters. But what can you do? What are the suitable methods for this kind of low disintegration? Yeah, electrokinetic disintegration, phytocavitation, surfactants, enzymes, reserved centrifuges, or ultrasonic. If you want more degree of disintegration, you can use ultrasonic or high pressure homogenizers. If you want a high degree of disintegration, then you have to use thermal methods or oxidation with ozone or thermal chemical methods. So only a little overview. If you think about disintegration on your wastewater treatment plant, another help for you if you think about to install a disintegration unit on your wastewater treatment plant. We think this will help you to decide. So first step, you have to define a target. Then you have to look where is your application area on the wastewater treatment plant. Then you have a selection of the procedure, the settings. Then you have to decide, do I want to make some laboratory trials? If yes, then you make it and then come to evaluation. If not, you have to make a literature-based evaluation. If you don't want to make laboratory trials, but we recommend you to make some trials because every sludge is other. Every wastewater treatment plant has its own sludge. So we recommend some trials, at least laboratory scale. So evaluation, then feasibility study, and then you have to ask you is it economic? If it is economic, if yes, you go further on. If not, you can decide. If you want to make a process variations, then you start up here at the beginning. If not, you can see the next. If not process variation, then no implementation. Yeah, you have decision. Your decision is no disintegration. But if you come to the conclusion it is not economic, then we recommend you to make parallel full-scale tests, if this is possible. Yeah? If this is possible, yes, you make it, and then you come to evaluation, and then feasibility study, And then you have to ask, is it economic or not? If not economic, and you can think over process variations. If not, you go here, no implementation. So parallel full-scale tests, no, you can test if it's possible to make serial full-scale tests. If this is also no deepened laboratory tests, yes, then implementation evaluation here is the economic process not. But if you come to the conclusion after your tests, yeah, is it economic, then we come to the realization. Yeah, short summary. Okay, the last 2 minutes for the summary. So application of SUSE-SWAP integration is preferred in secondary sludge, in surface sludge. The most widely used procedure is in secondary sludge. The targets are optimization of sludge characteristics, viscosity, setting, foam. The release of organic carbon for better degradation, especially in the digester, in the anaerobic digestion. But we also be aware that we have some negative secondary effects. Yeah? Nitrogen reload, for example, waterability is another thing. In most cases, a high energy input is needed for drastic increase of degradation. If you want a lot, or if you want much, you have to put a lot of energy inside. Ultrasonic thermal disintegration and dosage of enzymes are successful for optimization of anaerobic digestion. And installing of a disintegration technique requires previous tests. We recommend from our working group to make some tests. Not buy a disintegration unit and install it without any tests, previous tests. Besides the energy balance, the primary and secondary effects must be considered for the economic application of disintegration on wastewater treatment plants. That's it. Thank you for your attention.